see, Zaid is looking after me even here. One thing about Zaid though, everybody said Zaid is our brother. But Zaid is my brother too, so that makes me your brother. So we have to make sure that Zaid is our brother. Okay, so let's continue with our second presentation. Yes, go ahead.
Please, if we have one building, we have pressure from the front area, and we have pressure from the side area, and we have pressure on the roof and rear. When we design any building, we take it all in one case.
Okay, that's another very good question. So it depends as a structural engineer, what is your purpose? If you want to protect your building, the highest one will be the front wall. Okay, so but then you may have a glass on the side, you may have a concrete wall in the front, and you may feel that concrete is good enough and you want to look at sides. Sure, you do that. But if front and sides have same strength, then it is sufficient to do only the front load analysis, because there you have very high pressure, right? But if you're designing your beams that may be supporting your roof, then of course you need to know roof pressure. So typically you do front, side, and roof. Rear wall is usually not done unless you have a good reason, because it helps you, right? So you push the structure that way and rear pressure is helping you. And people usually don't do rear. It's acting in the other direction. And by the time shock wave travel passes the building all the way, go to the back of the building, the magnitude diminishes quite significantly. So this is a long answer to a short question, but you have the option of analyzing all sides, but typically people concentrate on front of the building because that's where you have the highest pressure. Any other question?
Yeah.
Yes.
Actually, I've spoke about external bombing. What if it happens in basement, as you have stated before? Inside the building itself, there is no distance over there. You have zero distance.
Okay. I was avoiding that because it's a complex problem. If you have close-in explosion, or if you have contact charge, in fact, I have a topic to give a lecture on that, it's completely different, right? So then the shock wave has not had a chance to form, because you need some distance, and that distance has to be equal to radius of the shock wave, which we haven't discussed in detail. So when shock wave forms, and it takes probably 5 meters to form, and then it starts going as a big wall of pressure. So if you have a building within that 5 meters, then it hasn't it hasn't fully formed, and then what happens is that you're in that excessive heat, excessive pressure zone. It starts causing material failure. It causes, I have a slide to show, it starts scabbing, it starts spalling concrete. Effect on material is more intense than the effect of member. Okay, this is called close-in solutions, close-in explosions. But the curves that I showed you, the US Army curves, do not apply to contact charge and close-in explosions. The problem becomes very complicated. You have to use software like Elastina or ANSYS to do competition fluid dynamics. And even there are challenges. How do you model material? They have their own materials. You have to trust them. Yes, but that's a different problem and more challenging problem. But perhaps the important answer to your question is it affects material rather than member. Any other question? Okay, so with that, we will now look at building standards and building codes and what do they do. I will give Canadian standard as an example, but as I said earlier in my introductory remarks, it is applicable to American ASC standard and Japanese standard and US Army standards. Okay? So this is our Canadian standard, and the objective is the same as any other standard. It's to protect people, the content, reduce damage to building occupants and human casualties, and reduce damage to building, and then also facilitate emergency access to the building. So these are the objectives of the standard. First step is to again go outside of our typical expertise and define threat. So in earthquake engineering, what do? We go to seismologists and they give us ground motions, right? As structural engineers or civil engineers, we don't know how to get ground motions. They develop them, they give them as tools. Building codes specify spectral accelerations. And those spectral accelerations were developed by seismologists. And then we take maximum spectral acceleration, design our building. And here, similarly, we need security professionals who define threat. So what's the threat? It's a lot of filling forms, and I personally don't like it, but I have to work with them because it involves filling a lot of forms. What's the probability of somebody attacking this building, right? It's a very difficult question to answer. And they look at probabilistic approaches, past experience, and they monitor security if there's a threat to these types of buildings, and they eventually come up with threat, okay? And threat is specified as charge weight and standoff distance. In Canada, Royal Military Police, RCMP, and security professionals do that. In the US, FBI does that. And they usually don't tell structural engineers why, right? Now I'm working to mitigate blast risk for a Canadian embassy in Northern Africa, and they want me to do the analysis, but they did not specify the threat level. They said, well, we have to come and give you verbally, nothing has to be in writing. What if somebody gets hold of it? That's how seriously they take it, right? So I have to have professional security clearance to work for government jobs, and I, just like now, I didn't tell you which country where the embassy is. You have to keep secret. So this is secret, but they eventually give you that we think that this embassy is likely to be attacked by a truck or a car, and the road, the closest road is about 15 meters away. So these are the parameters you have to use. So given that they gave me the charge weight and standoff distance, I immediately convert those to pressures and durations, okay? So the next challenge is a professional engineer, structural engineering challenge, and that is deciding on performance requirements. Now we are using performance-based design. Building owner, in that case, Global Affairs Canada, has to decide how important that building is. How much do they want to protect us, right? After all, it's an embassy, it's important, but it's not very, very important. So they may choose high level of protection, they may choose medium level of protection, they may choose low level of protection. Once they give that to you, as a structural engineer, you can't decide for them. The building owner has to tell you level of protection. Security professionals will give you a threat. With that two data, then you go and start crunching numbers, okay? So, performance objectives, having that piece of information, you have to limit, you have to control a number of things. First of all, you have to limit progressive collapse, and I'll talk about that at the end. And I already defined what progressive collapse is. You have to minimize damage to structural elements, and you have to mitigate damage to building envelope. Although some structural elements have collapsed in the past, as in the case of Oklahoma City bombing, as in the case of World Trade Center, New York parking garage bombing, but most of the time threats are to non-structural elements, building envelope, because masonry walls collapse.